Alright guys, we're going to take a look at question number 6. Which of the following equations has both 1 and -3 as solutions? Okay. Alright, so there's a lot of different ways to approach this question mathematically. I'm going to show you 2 different ways, and then I'm going to show you how to use the answer choices to find the answer. Alright, so let's take a look at this. So what does it mean, find the equation when the solution is x equals 1 and x equals -3? Okay. Well, first thing to realize is that that's what I'm saying. X equals 1 and x equals -3. That's what the solution means. That's what the equation is equal to. Okay. So what can I do here? Well, this is actually, from this we can derive the answer. So what we're going to do is we're going to subtract 1 from both sides, and we get x minus 1 equals 0. I'm going to add 3 to both sides, and I'm going to get x plus 3 equals 0. So you might turn and think to yourself, okay, Mr. Anderson, that's why do you want to do that? And it goes back to a principle called or a property called the zero property. And the zero property is basically that 0 times anything is 0. So if that is true, and both of these are equal to 0, then I can say x minus 1 times x plus 3 equals 0, right? Because if this is 0, 0 times whatever this is 0. And if this is 0, 0 times whatever this is going to be 0. So together, the product is going to be 0. All right? And then, how do you solve it? You FOIL, okay? So FOIL stands for first, outer, inner, last, okay? A lot of teachers show this in a lot of different ways. I'm going to go what foiling really is, which is just distribution. So distribution says x times x is what? X times x is x squared. Now be careful here, because earlier we were talking about x plus x, and x plus x is 2x. But now we're multiplying. And when you multiply two things together, you get two variables together, you get x squared. Okay? Then we're going to do x times 3, and x times 3 is 3x. Right? And then we get -1 times x, and -1 times x is -x, and -1 times 3 is -3. And that's all equals 0. So what did I do? I did x times x, x squared. X times 3, 3x. -1 times x, -1x. Note, I take the sign. And -1 times 3 is -3. Again, paying attention to the sign. Okay? So we're here. Can we combine like terms? Well, we have 3x and minus x, and that gives me 2x. So x squared plus 2x minus 3. Note, however, that I cannot put x squared and 3x or x squared and -x together, because those are not like terms. This is x squared is not the same thing as x. All right? Well, there you have it. There's your answer. X squared plus 2x minus 3. And that would be answer choice B. All right. So I said that's the 100%, even if I didn't have answer choices, way of solving this. The other ways you could go in reverse. You could factor each of these out. So I know that this is the answer, so I'm going to just play with this one. I could go x squared plus 2x minus 3 equals 0. And I want to factor it out, and I want to get to the point that I get x equals 1 and x equals -3. Okay, well then how do you factor? Well, factoring works like this. If the leading coefficient is 1, and for the most part this tends to be the case on the TSI, you're going to take 3, and you're going to ask yourself, what times what gives me 3, and when I add and subtract gives me 2. Now, teachers have different ways. I've seen like this little X method and whatnot, but I'm just going to go straight forward at it. I'm going to say what times what is 3. I'm going to say 3 times 1 is 3, right? 3 is what's known as a prime number. And what is a prime number? A prime number just basically means a number is only divisible by 1 and another factor. And the only other factor here is 1 and 3. Okay? So 1 and 3 is prime. So that's the only way it's going to work. So I got to ask myself, can I add or subtract 3 and 1 and get 2? And the answer is yes. 3 minus 1 is 2. Now I'm going to pay attention to the sign now. I'm going to approach this like this. I need to get a positive 2, which means that of these two, the positive one is going to be the bigger one, and the negative is going to be the smaller. Okay? So 3 is positive, -1 is is negative. Or rather, 3 is positive and 1 is negative. So this becomes x plus 3, x minus 1 equals 0. And when I solve this, that becomes x plus 3 equals 0, x minus 1 equals 0, and then subtract 3 from both sides, add 1 to both sides. Boom. X equals negative 3, and x equals 1. Okay? Notice that what I did here, if I go from here up, it's essentially is what I did here, right? The same process. So these are two different ways of approaching this problem, but really you're doing the same thing. In one step you're going from the answers to, or I guess from the question to the answer. The other way you're going from the answer to the question. But they're basically the same process, just in reverse. Okay? Now there's a third way, there's a tertiary way of doing this. And the third way of approaching this problem is if the answer is 1 and negative 3, then I can substitute in 1 and negative 3 and it should equal 0. So I'm not going to do this for all the answer choices because I know what the answer is. And I'm just going to approach x squared plus 2x minus 3 and I'm going to substitute it in. So that would be 1 squared plus 2 times 1 minus 3. And 1 squared is 1. 2 times 1 is 2. And minus 3 is obviously minus 3. This is 3 minus 3, which is 0, so this is true. Okay? Keep note, or do note, that when I did this, exponents comes first, and then I multiplied, and then I added. Why? And I hope you're thinking when you see this that you think about Pemdas. Okay? And Pemdas obviously means parentheses first, exponents. Multiplication, division, I boxed these because actually multiplication and division are essentially the same thing. So the order here doesn't matter, which is also why you can divide out things and get 1 or 2 or whatever. And add and subtraction operates the same way. Subtracting is just adding negative numbers. So these two are grouped together as well. You can do them in any order. Okay? So you have to follow Pemdas. And Pemdas actually applies to all of mathematics. And this maybe somewhere else we'll see an example of how PEMDAS applies to other situations besides these stereotypical types that we usually see. Okay, so anyways, back to this. We're going to redo this. I'm going to just rewrite it just so that because I get confused very easily. And I'm just going to substitute back in the other number. So the other number was negative 3. So if I plug in negative 3 squared plus 2 times negative 3 minus 3. Following PEMDAS again, I'm going to do exponents first. So that's 9. Note here it really does matter. 2 times negative 3 is negative 6 minus 3. And if you look here, negative 6 minus 3, a negative minus 3, or a negative and a negative becomes, you add them together, you get negative 9. Think of it as I'm taking $6 from you, and then I take another $3 from you, so I've taken a total of 9. Or if you like the sports example, think of it as you're being pushed back 6 yards, then you're being pushed back another 3. So you're being pushed back a total of 9. In any case, 9 minus 9 is 0. All right? Now, this doesn't apply to the TSI, but this does apply to most of the mathematics that you do in high school because you are typically given a calculator in high school. When you put in negative 3 squared, this goes back to PEMDAS, you have to actually type it in as negative 3 in parentheses squared. Because if you do just negative 3 squared, what this means, following PEMDAS, is that you do 3 squared and then you multiply by the negative. Or actually, this is technically negative 1. So this is actually equal to negative 9. But this, in parentheses, means I'm doing negative 3 times negative 3, which is 9. Okay? I put, most of the time if you're doing this by hand, most people realize negative 3 squared is 9. But when they type it in the calculator, they usually type it in like this. And they end up getting negative 9, and without realizing it, they miss the question. Okay? At the end of the day, you see that since both of these give me 0, right? Since both of these give me 0, this equation is the correct equation. Okay? I want to note, though, that if you do this, you do want to go through all of these. Only one should work, but you still want to test every single one. And you have to test with both numbers. Okay? Something else that's important here is that when you're testing with the numbers, sometimes I see craziness. I see students put in 1 for the first one and negative 3 for the second one. You can't, that's not what it's saying. It's saying 1, x is 1, and x is negative 3. So if x is 1, both of these are 1, and if x is negative 3, both of these are negative 3. It doesn't mean you combine the two, okay? So don't do that. work through all of them. It's tedious. It takes time. But if you want to be successful, you want to be able to check every single one, because look, we all make mistakes. All right. So hopefully this helps you out. This is actually a really important problem. Make sure you know how to do this. Make sure you're comfortable with all of these methods. And hopefully you can use all of these methods on a test. And maybe you can go through, if you have a question like this, and solve it 3 different ways and check to make sure you get the right answer. All right? Leave me some comments. Let me know what you think, and I'll see you in the next video.